Hello students, in this lecture we will discuss about the properties of the fuels which are used for generating the electricity by using the thermal power plant. Okay, now the first we will start with the fossil fuels. All fossil fuels were produced from the fossilization of the carbohydrate components. The three types of fossil fuels used in the power plants are coal, oil, gas. Out of this, coal is the predominant source of energy in India and many other countries. Now, first we will discuss about the coal. Coal, the most abundant fossil fuel, was formed by decomposition of the vegetation which was buried under the earth millions years of ago. About 20 meters of compacted vegetations are necessary to produce 1 meter thick stream of coal. This compacted vegetation, in absence of air and under the influence of high pressure and temperature under the earth, was converted into peat, which is the very low grade coal, then into brown coal, then into lignite, then into semi-bituminous, then into bituminous, and finally into the anthracite coal. As the aging process progresses, the coal becomes harder. Oxygen content decreases, moisture content usually decreases, and carbon content increases. The conversion of vegetation into coal requires ages of times. Coal contains moisture, carbon, hydrogen, sulfur, nitrogen, oxygen, and ash. So basically, coal is the most widely used fuel all over the world. It is formed by decomposition of the vegetation that just we have discussed buried under the earth millions of years ago. Okay, and in the conversion process, the first thing is called as the peat. Peat is the first stage of conversion of vegetation into coal. It has high percentage of moisture, nearly 60 to 90% moisture, and low carbon content, 5 to 20% carbon. Its calorific value is 8000 kilojoule per kg. And because of this higher percentage of moisture and low calorific value, it is not suitable for use in the thermal power plant. Then second stage of conversion of vegetation is the lignite. Lignite has about 30 to 50% moisture and 20 to 40% carbon. When exposed to air, its moisture content decreases appreciably. It can be used in pulverized form for generation of electrical energy, as its calorific value is nearly 20,000 kilojoule per kg. Then the next step of the conversion is bituminous coal. It is the most common variety of coal and widely used for almost all purpose. It has low moisture content, about 60 to 80% of carbon and 6 to 10% of ash. Semi-bituminous coal has properties in between those bituminous and anthracite coal, and it is widely used in the power plant. Its calorific value is nearly 27 kilojoule per kg. And the last stage of conversion is the anthracite coal. It is very hard and has the highest percentage of carbon. It is difficult to pulverize this coal. Its calorific value is about 30,000 kilojoule per kg. Then we are going to focus on liquid fuels. Okay, so basically the liquid fuels are obtained by refining the crude oil, that is petroleum product, which contain 84 to 87% carbon, 10 to 16% hydrogen and oxygen, nitrogen and sulfur. Okay, liquid fuels have the number of advantage over coal. They are easy to handle, store, transport and burn. There is no problem of ash disposal, and plant using liquid fuels can meet the load changes very quickly. However, they are costly as compared to other sources of energy. So basically there are some types of liquid fuels commonly used. That is, first one is the naphtha. Naphtha is higher end petroleum product and is very commonly used in the petrochemical industries. It is the cleanest of liquid fuel and It is common liquid fuel used in Europe. Its advantages include low cost, low emission, good availability, and good turbine efficiency. Okay, the density of naphtha is 0.66 kg per meter cube. Its calorific value is 11,200 kilocalorie per kg. Okay, it has very less sulfur content, nearly 0.2% of the mass. Okay, so these are something about naphtha. Naphtha require careful handling and storage to ensure that the product does not get contaminated with the alkali metal, that is sodium, potassium and lithium. Strict guidelines on handling and storage must be adhered because its flash point is generally below the ambient temperature. So you need to just carefully handle the naphtha and its cycle efficiency about 41%. Then next commonly used liquid fuel is the high speed diesel. Okay, so it is known as the gas oil. It has high calorific value, but it is also very expensive. It is a cleaner than fuel oil. The government does not encourage the use of high speed diesel for power generation because it is extensively used in the transportation and agriculture. For diesel pumps, tractors, its price will be subsidized. Then next commonly used is ore emulsion. It is a fossil fuel and it is basically emulsion consisting of natural bitumen dispersed in the fresh water in 70-30 ratio. It can be transported by tanker or pipelines. Its calorific value is nearly 7,000 kilocalorie per kg and its ash content is very low, 0.2%. However, its sulfur content is high, that is about 2.8%. The existing plant using fuel oil can switch over to the ore emulsion with only minor modification. The overall composition is 26.4% oxygen, carbon 60.1%, hydrogen 10.1%, sulfur 2.8%. Okay, but its sources are limited. This is found only in Venezuela. Then next is the gas turbine fuel oil. It is a low sulfur fuel and it is cheaper than high speed diesel. However, the gas turbine using this fuel need more frequent maintenance. It is being widely used nowadays. And next is the condensate. These are very high crude oils. These are the very light crude oil produced in association with either natural gas or crude oil. There are two types, clean and dirty. Clean condensate is known as a natural gas liquid or NGL. It is produced by condensing the higher boiling compound in a gas field, segregating the steam and handling the product like light refined product. This process ensure good quality product. Second one is the dirty condensate is derived from the crude oil fields. The crude oil is effectively split between light and main crude fraction to improve the stability. The calorific value of condensate is nearly 11,000 kilocalorie per kg. The sulfur and methane contents are low. Then next is the gaseous fuel, natural gas. Natural gas is usually trapped in the limestone casing on the top of the petroleum reservoir. It has about 80% methane and has small fraction of other gases. Its calorific value is 50,000 kilojoule per kg. Natural gas is very easy to burn and it mixes well with air. It can easily transported in pipelines. However, it is difficult to store in large quantities. Natural gas is a clean and eco-friendly fuel. Its sulfur content is low. Carbon dioxide, nitrogen oxide emissions are lower than that of coal-based power plant. Gas have the low gestation period and high efficiency. The only disadvantage of natural gas is that infrastructure to transport the gas needs a lot of time for the development. Then we are going to discuss the fuels which are used for the nuclear power plant. The nuclear fuels used in the nuclear reactors are natural uranium, slightly enriched uranium dioxide, and plutonium. Natural uranium contains about 0.7% uranium 235, which is fissile in thermal neutron flux. It is a hard and dense tough metal. 1 ton of natural uranium produces a heat equivalent to 10,000 tons of coal. However, the capital cost of nuclear reactor is so high that the cost of generation in the nuclear plant is higher than that of coal-fired power plant. Then next is uranium dioxide. It is a brittle ceramic compound as a powder and then sintered to form a pellets. It is more stable than natural uranium and presents less problem of oxidation. It does not corrode as easily as natural uranium. It advantage in advanced gas-cooled reactor, 1 ton of uranium dioxide produces heat equivalent to 75 tons of coal. Then uranium carbide is another nuclear fuel. It is black ceramic used in the form of pellets. It has high melting point, possesses good thermal conductivity, and is free from trouble of phase changes. It is not economical to use as a fuel. Then the last is the plutonium 239 is most likely to be used in the fast reactor. It is highly toxic. If it enters the body, it is retained in the bone lining where the alpha particle damage the bone marrow and adjacent bone forming tissue. All works on plutonium must be conducted in the hermetically sealed gloss boxes. So these are the some things that commonly used for generating the electricity. Okay,